Students and friends, welcome to my YouTube channels. Today I am going to discuss one problem where they are asking find the reactions of the each contact point. So what how the questions they given? Cylindrical roller, two rollers is there. Of weight, both weight is 50 Newton, 50 Newton. Placed as shown in the figure. They are asking find the reactions of the each point. Or sometimes they'll ask for reactions at the contact point, reactions at the C point. If objective questions like this will be there also now. This generally questions will asking in the GATE and university exam also. So this is the given diagrams will be there. Now what we have to do? We have to apply the little geometry here. So we draw here two circle O1, O2 I taken. Then we will see the distance. This is the radius the given 0.3. So if we draw this distance will be 0.3 meter. And this side also, this is the radius. So if we project this line, this will be also 0.3 meter. 0.3 meter. Total length they given 1. Total length they given 1. So 1 minus 0.6 it will come 0.4. It will come 0.4 meter. So all are in meter. So I am not writing degrees. All are in the meter. Now again what we'll do? We'll take this triangle out first. This distance suppose A, B, C, D, E. This take it E. So I am taking this triangle out. That is O1, O2, O2 and this is E. And assuming this angle will be alpha. This angle will be alpha. So what is the distance given? This distance they given 4 meter, 0.4 meter. Then what is this O1, O2 distance? O1, O2 distance means what is? O1, O2 nothing but R1, R2. R1 plus R2. So this is 0.3 plus 0.3 equal to 0.6 meter coming. So this coming 0.6. 0.6. So we will find the alpha. So right angle triangle we know by the Pythagoras theorem. If base and hypotenuse is there means we will write the cos alpha. Cos alpha equal to B by H. B na 0.4 by 0.6. If this will calculate, alpha will come 48 point, I think we calculated 48.19. Alpha will come 48.19 degree. Alpha we know now. So we know this alpha. Now what we'll do? We'll draw the free body diagram. That will be the very important in like this diagram. So free body diagram we'll draw for this. So how to draw the free body diagram? For both circle, we'll take the center. We'll draw the circle just like a rough diagram. And here also we'll draw one this circle similar. We'll draw a circle here. So we draw the circle. Just a free hint, not required more circles should come. Just free hand, we'll draw one circle. So okay. So both center O1, O2 would draw. Now contact point, contact wall and this is cylinder. So what will the contact point? Contact point once we are removing reactions will be there RA. Once you are separating this two body, at that point reactions will be there. Now reactions B will act here RB. Then weight is there. Weight will act vertically downward and it passes through the center. So this is the 50 Newton, that is the weight acting O1. Now once two circle we are removing, so if contact point D, action and reactions will come equal and opposite. So what we will do now? Little circle, little distance will be there now. It will be easy for us to draw. Little bigger diagrams will draw now. It will be more understandable. So circles will be here. So this, once we are separating, both equal and opposite reactions will take place in the center. In the center will take the reaction. Now what is contact point it here? At RC. And again, weight will be there, both having 50 Newton. So weight will act 50 Newton vertically downward. This is called O2. O2. Now already we know inclined force having two components. Inclined force having two components. Suppose this is force F1, angle alpha. How to resolve? With respect to horizontal, draw one line. With respect to horizontal, draw one line. And with respect to this force now, mutually perpendicular. This is the resolution of forces. This angle alpha, this angle also will be alpha. So here already we have, suppose this geometry will, this is a triangle. This angle will be alpha. This angle will be alpha, not visible. So this angle will be alpha. So already alpha you know 0.48.19. So how to resolve this? So this is the inclined force. So with respect to horizontal, we draw one line, mutually perpendicular this will draw. So this alpha, this also alpha. So what is the resolution of this? This, suppose you have taken D now, D. So RD cos alpha. This is RD sin alpha. Similarly, if we resolve this also, what will come? This is the resolution. We'll draw this in different color. So if this point also will resolve, and this is the alpha here. This two will be there. This angle alpha, this angle will be alpha. So near angle always will be cos component. So this what will come? This will come again here, RD cos alpha. This one will come RD sin alpha. So why here sin? Why this is cos? So near angle always cos component, far angle sin component. So here also this angle alpha. So this will be alpha here. This alpha na, this is the cos component. So we resolve everything. We resolved this. Now this load also is there, reactions already see. So everything will resolve. Now what we'll do? We'll apply the equilibrium equation. Equilibrium equations will apply and we'll get the answer here. And also one more thing, suppose some point, if will three forces passing through the same point, suppose passing through the same point, and both are should be coplanar and concurrent, then we'll apply the lami theorem also. So here if you see the one force, two force, three, four force, here we cannot apply, but here we can apply. So that way also we can solve. But here equilibrium equations will be more easily we can solve. So what we'll do here, we'll apply the equilibrium equations at block 1. Applying equilibrium equation block 1. In block 1. So what will be the sigma Fh equal to 0? That means total horizontal force, total leftward equal to total rightward force will take from this O1. So Ra going this side, rightward Ra, then coming Rd equal to Rd cos alpha. Alpha we can take how much? 48.19 degree. 48.19 degree. So total leftward force equal to rightward force for this part, this block 1. Then sigma Fv equal to, this you give equations number 1. Sigma F equal to 0 now, what will write? Total upward force equal to total downward force. We'll check. Downward force is coming, upward force going Rb. Okay, Rb is Rb upward force. Any upward force? No. This and this downward force. So equal to 50 plus Rd sin 48.19 degree. This we know the second equations 2. Block 1 Ra equal to Rd cos alpha, horizontal, vertical 50 plus this equal to this. Okay. Now we'll go the block 2. And we'll go the block 2. block 2, or you write block 2. So block 2 again, what will write? Total horizontal force again equal to 0. So here also leftward force is equal to rightward force. What will write? RC, or this RD cos alpha. Alpha means 48.19 equal to RC. So this force equal to this force. Now upward force and downward force. So total vertical force equal to 0. Total upward force equal to total downward force. What will write here? Upward force going RD sine 48.19 equal to 50. 2 is going to leftward to downward. So now see here. One by one we'll calculate, we'll get all the reactions here. So see where we will unknown, here 2 unknown, here also 2 unknown, here also 2 unknown, here is 1 unknown. So we'll substitute value. So we'll get the RD here. So that implies RD is equal to 50 by sine 48.19. What is the value of sine 48.19? Already we calculated, we kept ready. 0.75. Sine 48.19. How will say the calculator? Calculator sine operates sine, then 48.19, close the bracket, equal to na, this will come 0.075. So RD value is coming here 66.67. 66.67 Newton. RD value is coming here 66.6 Newton. So one value we know now, one reaction. So in exam, if university exam na full question they will find the contact reactions at all the contact point. Competitive exam, any one reaction they will ask. But you have to know the full process. So now RD, where will substitute the RD? If we will substitute here equations 3, substitute RD in equation 3. If substitute RD in equation 3, then we'll get RC here. RC is equal to RD na 66.67 into cos 48.19. Cos 48.19, how much is coming here? Already you calculated 0.67. 0.67. If we calculate this RC value, you will get RC value will be 44.45. 44.45 Newton. So now you know the RC value. RC value you know, second equation. Now what we'll do, where we'll come here equation 1 and 2. So here RD we know, so RB we can get here. So RB is equal to 50 plus RD 66.67 into sine 48.19. Sine 48.19 value will have 0.67. Sine 48.75. So into 0.75. So this value will come 50 plus this value will come RB. So it will come 100 point something. So 100 we can write 100 Newton. So we got this value 100 Newton RD. Now RD substitute in equation 1. If RD is substitute equations 1, so we will get the RA. So RD how much? 66.67 into cos 48.1. So that value how much? That also 0.67. 0.67. So this value will come also same 67 of 44.45 Newton. So this way we can calculate all the reactions. So we'll check it here. RA value is coming. RA 44.45 Newton. RB coming 100 Newton, correct? Then RD 66.67 Newton. RC coming 44.5 Newton. So this way we can calculate the problem. So look at here. If they given this diagram, first apply the geometry here, and we'll see this all the distance here. Eastern, because this is radius, this total distance is 1, so this is 0.4. So 0.4 and 0.6 we apply the cos of, because B by H cos theta, so cos of apply point, we got the angle. Once we got the angle, resolve this part, and where is the contact point will be there only reactions will act, and apply the two equilibrium equations, we can get the answer. In this point, we can apply the Lami theorem. Two forces is there, but not required. Already one resistance forces going, so we will go get the same method. Okay, so this way we can solve the problems. Okay, friends, watch the video, share this video to your friends. Okay, subscribe the channel, those still not subscribe the channel. Okay, thank you.